Hello, everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to Technical Session 5B. My name is Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th World Conference on Smart Trends in Systems, Security, and Sustainability, WS4 2025, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 19th August, and the virtual event is being held today and was being held yesterday through Zoom, that is on 20th and 21st of August 2025. I hope you all will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. And on 10 minutes, I'll be raising a general reminder. There's another request to all the participants to please stay connected with us till the closing of the session. And if you have any query or update, then you can write it to me in the chat box. Now, before starting with the session, I'd just like to introduce you all to the chairs for this session. We have Dr. M. Shamim Kesar. He is a professor at the Institute of Information Technology, Jahangirnagar University, Sawar, Dhaka, Bangladesh. He serves as Associate Editor for Cognitive Computation and IEEE Access, a life member of the Bangladesh Electronic Society and Bangladesh Physical Society. His research interests include applied data science, computational neuroscience, big data analysis, cybersecurity, machine learning, cloud computing, high-speed multi-hop communication, and smart healthcare. We welcome you to the session, sir.
Thank you.
And we have another section chair, Dr. Navneet Sharma. He's an associate professor in the Department of Computer Science and IT at IIS University, Jaipur, with over 19 years of teaching experience at both undergraduate and postgraduate levels. He is actively associated with more than 15 universities and academic associations for various scholarly activities. His research interests span e-commerce, cloud computing, and network security, and he has been published over 25 research papers in reputed international journals. We welcome you to the session, sir. Now we'll be moving on to the very first presenter of the session, Varun Sharma, with the paper titled Decentralized Marketplace for Large Language Model Merging, Buying Models, Selling Models, Fine-Tuning of Models. Do we have Varun here in the session?
Yeah, ma'am, I am there. Thank you so much, ma'am, for giving me this great opportunity. And it's a pleasure to be here. I am sharing my screen. Ma'am, it's visible?
Yes, it's visible.
Just a second. So, ma'am, I'm starting the PPT. It's visible, right?
Yes, it's
Yes, sir,
visible.
visible.
Yeah.
You
Hey,
may
good morning, good afternoon, and good evening to everyone. So, my name is Varun Sharma, and I am a Python developer and an AI full stack engineer at Ordis Labs. And I am delighted to present on this groundbreaking topic today. This presentation is based on our paper authored by myself and my co-author just conversing. And I want to be transparent that currently this marketplace is a theoretical framework that we believe can be developed in the future. And we are presenting our findings, the experimental validations, and the technical roadmap for the implementations. Today, we will explore a revolutionary approach to making the AI development accessible to everyone through the decentralized technologies. So our experiments that we have conducted demonstrate the technical feasibility through the model merging, fine tuning, and the blockchain integration. So right now, the LLM landscape today is completely dominated by the resource-intensive centralized systems that create barriers that most of us probably can't overcome. Like training a single large language model costs us only millions of dollars, and only the tech giants like the Meta, OpenAI, and Google can afford. And this creates a digital divide that locks developers in the developing nations, startups, and the independent researchers. So our paper presents an idea, and we have think of a solution that a decentralized marketplace framework will be there that empowers the communities to select, merge, and fine tune the pre-trained language models. So imagine that users could pick the models from Hugging Face, because on Hugging Face there are 4 lakh plus models. So that can be fetched. And then we can apply the advanced merging algorithms like Dare, Tires, Dare, and Slurp. And then parameter efficient tuning using QLoRa and Unsloth can be done. So every resulting model would be minted as an NFT for the transparent ownership as well as the automated royalty management. So we are proposing such a sustainable economy where every contributor gets fairly compensated through the blockchain-based smart contracts. So we have validated the key components through our real experiments, and we successfully merged using the advanced algorithm Dare Tires method in just 6.5 minutes with 0.52% updates with the Hugging Face integration. So this is the decentralized marketplace architecture, and it's divided into 4 interconnected layers. First one is the service layer. And service layer basically acts as the user gateway for browsing the model repositories and comparing the architectures. So we successfully integrated with the Hugging Face API and proving users could seamlessly browse over, as I told, 4 plus lakh models there. Second one is the blockchain layer. So this basically forms the trust foundation using the Ethereum smart contracts, basically to record the transactions, manage the NFT ownership, and automated royalty distribution is being handled in blockchain layer. And we have tested the prototypes that ensure the complete transparency and security provision is there, where every model ownership history are immutably recorded on chain, and it can't be altered because CID is there, content identifier is there, which is being created. So third is the control layer. Control layer basically handles the actual model merging through the sophisticated weight combination using the techniques slurp tiles, data tiles one, and we merged successfully the DeepSeek and the Yomai models, and we integrated with the IPFS storage, interplanetary storage, and validated the fine tuning using Unsloth and QLoRa. And fourth one and the last one is the transaction layer. It governs the economic activities basically, and the smart contracts manage the on-chain purchases, the NFT trades, and the automated royalty settlements. So as you can see on the slide, these are the model merging strategies, and we combine the models at the parameter level, creating a entirely new capability. These are all the merge kit library methods. This averaging, parameter averaging, slurp, ties, data ties, med merge, and many other more. So parameter averaging is like just like that. It's effective for same family models, like 7 billion parameter model with 7 billion one, Mistral with DeepSeek. So both are 7 billion. So these are similar. And producing a balanced hybrids that inherit complementary strengths. Slurp means spherical linear interpolation. And basically, it treats the model on high dimensional spheres. This maintains the model coherence while blending capabilities. Now is the tires method, this trim, select, elect, sign, and the merge one. And it demonstrates the intelligent parameter selection. But in tires, the approach is that only matching sign parameters merge. they need to be little bit, the hidden layers need to be same, the weights and biases. And it significantly reduces the interference while preserving the specialized capability. The DARE tires is the most advanced algorithm that we have used also. And like this randomly drops the low density weights before applying the tires logic. And it's much more sparser, but more robust models. And we achieve the size reduction while maintaining the performance. So these all techniques which I told you, or model merging strategies, enable the rapid customization without fully retraining and reduce the competition requirement. So these are all the efficient fine tuning methods, and right now these are very hot in the market as well. So we transform the generic models into specialized tools using fine tuning, and we have validated the parameter techniques that reduce the cost while maintaining quality. The QLoRa basically, which means quantized low rank adaptation adapter, it integrates the revolutionary accessibility through 4-bit quantization NF41, and it reduced the memory. So we have basically fine-tuned the 7 billion models on the consumer GPU, and we use the 172 training samples dataset. We use like from Kaggle or from Hugging Face or any other, we can use the dataset. And we achieved the loss reduction from 1.2 to 1.0, only updating 0.5% of parameters. The LoRa you can see is low rank adaptation. So it validates the low rank matrices that approximate weight updates. So instead of updating millions of parameters, we just train only tiny matrices. You can say out of uh, 50-60%, only 0.1% of total parameters we are training in the matrix. Unslot PEFT optimization, the parameter efficient tuning, is another thing which efficiently fine tunes and frees the base weights. And it adds the small task specific adapters on the top of the LLM. And it reduces the build and the storage by enabling multitask learning. The Unslot optimization is the much more faster, and it's, you can say, 2 times faster than this QLoRa one. QLoRa is mostly for memory efficiency, and Unsloth is this one with the less memory thing. So Unsloth plus QLoRa experiments fine-tuned the 8 billion models in the 10 minutes using just 41 billion trainable parameters. So these all techniques enable anyone to customize billion parameters model, reducing fine-tuning from days to minutes. So these are the experiment setups and the results. And here, like you can see, our approach we have and the experiments we conducted is technically sound and it's practically implementable also. And we used a single NVIDIA T4 GPU for this with 16 GB VRAM. On Google Colab, we tested the fine-tuning portion, QLoRa and Unsloth. And for merge kit is also a method we used for it's a library for merging the models. And the experiments included the DeepSeek R1 distilled Llama 8B with the 8 billion parameters and the Llama 27B chat with the 7 billion parameters. So we use the 172 mental length and constant examples as I told you. And uh, for Unsloth, we kept the initial loss at 3.3, as you can see in this graph also, and it dropped to 2.7 after just 10 minutes. So we updated the 42 million parameters out of 8 billions. You can say just 0.52%. And memory usage was 6.2 gigahertz compared to the 32 gigahertz. For and for the QLoRa, basically the training took 12 minutes, the experiments that we conducted, and we updated 35 million out of 7 billion parameters. The loss reduced from 1.2 to 1.0, which is the 16% improvement we achieved. And the merge kit, as I told you, with the data tires one, completed in just 6.5 minutes. And so this is the NFT and the monetization flow. So it works like this manner that first of all, the economic layer is makes this ecosystem sustainable when the models are merged and fine-tuned. Each becomes an NFT on Ethereum. creating the immutable records. Immutable means that can't be altered or modified, and records of the parent models, strategies, and the hyperparameters. The smart contracts basically handle everything automatically. But the buyer purchases the cryptocurrency with instant ownership transfer, and the royalty flowed automatically to all the contributors forever. So, if I give you an example in this monetization flow, someone might find you in a model for legal documents and mint it as an NFT and send it to the law firms. But the original creators and the fine tuners would receive the predetermined royalties encoded in smart contracts. And the developers can basically monetize directly without the intermediaries, and small teams can compete through the specialization, and individual developers can earn passive income from their contributions through royalty automation. Every transaction is recorded on chain, and the royalty distribute within seconds in this workflow. So this is the decentralized storage and the security slide. And here for the storage, we leverage the Lighthouse SDK. It's a platform. It's based on IPFS and Filecoin. Lighthouse SDK, software development kit, and the models are encrypted with the AES 256 encryption algorithm, chunked into 256 kilobyte pieces, which each receiving a unique cryptographic CID, which ensures the integrity. As I told you, we validate the Lighthouse SDK for permanent storage. Like AWS and GCP Cloud, that charges $200 annually. This Lighthouse approach offers one-time payment and one-time storage, permanent storage for with 50 to $100 payment. And the storage providers must put up tokens as a guarantee. If they fail to maintain your model, they lose their money. So CID just works like fingerprint for your model. If anyone even changes a bit of data, so basically the whole block change, and the CID completely changes, and like you can say, so you always know if someone tampered with your model. So it's impossible to fake these fingerprints for CID. For privacy protection, on-chain hashes record the model information immediately. Any tampering gets detected immediately, and the homographic encryption allows the computation on encrypted models without relieving the actual weights. So, access control ensures that only authorized users can reach your model data. Everything has multiple security layers like encryption, distribution, verification, making it much safer than the traditional storage. That for the centralized system, people use the traditional storage. So, yeah, this is the marketplace workflow, and it demonstrates the seamless component integration. So step one is that users navigate Hugging Face interface, exploring the models. Any model from there can be explored. We tested by fetching the Hugging Face models and its API we used, uh, and also metadata extraction and the compatibility analysis. Step two is that the platform recommends merging approaches. Same architecture uses Slurp, and specialized combination use tires or data tires. Step three is that users upload data sets or select curated collections. So they can choose Unsloth for the speed and Qlora, as I told you, for memory efficiency can be chosen. And step four is that
That you have completed the 12 minutes. This or just a request to
just one
complete.
slide is left. Just only one is
No
left.
problem. Yeah.
Yeah. So step three is that users uploads the data set, which I told you, and step four is that the models encrypt and store on IPFS Filecoin with the on-chain. So smart contracts establish ownership and royalties. Step five is one that users list the model flexibility, and others can purchase access the API, and the royalty flows automatically. So this transforms the closed AI development to open collaboration, enabling anyone to participate and profit. So this basically like tells that our findings prove that the parameter efficient techniques that we have done also updates less than 1% of weights while achieving significant improvements. Onslaught achieved 0.52% updates, and 42 million out of 8 billion parameters got updated, and QLoRa managed with 0.5%. And this means that developers globally can merge models from different sources, and small teams can compete with giants through specialization. So we are working on developing multi-model models, expanding beyond text and automated cross-architecture merging. So we are enabling a future where AI development is truly accessible to everyone, and the developers globally can collaborate and prosper through the specialized development. And here, NFT basically provides the unique ownership. Each model becomes an asset you can own, you can sell, you can lease, or as well as you can share while maintaining your ownership and receiving royalties. So everyone can access the AI model without relying on software companies. So this creates a global open AI economy where innovation comes from the collaboration. Thank you so much for your attention. This collaboration between Just Conversing and myself presents our vision for the AI evolution, which is fair and accessible to all. Thank you so much. Yeah, I'm done with the presentation.
I have a question. Can I ask a question?
Yes, sir, sure.
Yeah, I have seen it's a wonderful work, but would you please tell us about the model merging complexity? Because merging LLM with
Mm,
a system is not a trivial task, right? It
yeah.
requires alignment, uh, layer compatibility, as well as the tuning, right? So
Mm.
actually, how you handle this issue?
Like the complexity you are saying in the model merging, the weights and
Right,
bias.
right, right. Yeah, yeah. Merging
Okay.
complexity.
Yeah.
Yes.
So actually we have thought that slurp and the tires approach for this, because these are the parameter averaging, the slurp and the tires are mostly used for the same architecture. And there is already a Python framework, which is the merge kit library we can use for merging the models. And right now the complexity would not be too much because you need to just a configuration is there, a YAML configuration is there. You need to put your weights. Suppose if you are giving the base model, you give DeepSeek, you give it uh, zero point 0.9 density, and for the other one you take, you give it zero point 0.1 density. So the weights are combined, and the results you will get uh, like on the basis of the YAML configuration. And if like there is one more functionality also in this merge kit library, which I told you, med merge algorithm is also there. I think so. I forgot that in the slide. That can help in also cross model architecture merging. Like suppose the hidden layers are completely different in two models when you are merging. So you can merge them also, but needs to be little bit same. But if totally different, then we have made a approach, and we have like worked on that also and made one approach where you can do the knowledge distillation by like
Okay,
knowledge.
I
Yeah,
got it. Okay,
yeah,
thank you. Thank you so
yeah.
much.
Thank you so much, sir.
One question from my side.
Yes, sir, sure.
In your presentation, you told that you have tuned 82 million parameters in your
Yes, sir.
market. Okay.
Hmm.
So what strategy you would follow for that
Sir, for like you are saying about the Unsloth or the Qlora one, or both of them?
portal?
Yes, so for that thing, we basically like LoRa is also an approach, but we considered the Q LoRa as the most efficient, the quantization one, because like suppose if there are 16-bit quantization and you want to train 82 billion parameters model. So
Mm,
Q LoRa basically solves your that thing, and it quantize the 16-bit into 4-bit or 8-bit. And so because like it will consume your GPU space completely. Like out of 100%, 85% will be consumed if you do the normal fine tuning. So QLoRa resolves that thing, and there it's like a quantization. There is a bits and bytes library in Python which can help
mm,
you in like solving this thing, and it automatically does everything, and it fetches the safe tensors. Basically, there are safe tensors in Hugging Face and tokenizers and the config files. These are fetched and automatically based on your the configuration. As I told you. That thing that works basically in Unsloth also. The approach works similarly, but Unsloth is mostly when you are having the GPU servers. and you need the NVIDIA setup also for the unsloth approach.
Okay. Okay. Thank you.
Yeah,
Thank you so much.
yeah. Thank you so much, sir.
Thank you for the presentation.
Yeah, thank you so much, ma'am.
Now we'll be moving forward to the next presentation, and we have Ezekiel Santos with the paper titled Fruitafia Information and Communication Technology in Circular Food Networks, a scoping review. Do we have Ezekiel in the session?
Yes. Yes.
Yes. Yeah, you can start already.
So, good morning, everyone. Today, I will present our scoping review titled Fruta Feia, Information and Communication Technology in Circular Food Networks. This work maps the academic literature on Fruta Feia. Fruta Feia is a Portuguese cooperative that rescues so-called ugly fruits and vegetables and explores how information technology, or ICT, appears in that research. This study was carried with my supervisors Claudia and Vitor from IAD and IPCA. So why food waste matters? Food waste is a global issue with massive environmental impact, and according the European Commission, food hierarchy, prevention at the source is the first step on the chain to avoid any step of food waste, because this hierarchy consider spending energy to producing food. So it's considered, for example, even the level of composting as not waste the food because you can reuse that energy. But in the case of our example, we are trying to prevent at the source. So, in the big picture, globally, 1/3 of the food produced is never eaten, over 1 gigaton in 2022. This waste accounts 8 to 10% of global greenhouse gas emissions, which is more than the entire aviation sector. So, economically, the loss exceed $1 trillion per year, and ecologically, it means almost 1/3 of all the land used to produce food is discarded. So food waste is not a small issue. It's central in terms of social, climate changes, resource efficiency, and food security. What is fruta feia? So fruta feia means ugly fruit in Portuguese, and Fruta Feia is a Portuguese non-profit cooperative founded in 2013. The model they operate is very simple. They buy fruit and vegetables that supermarkets will reject from producers because of cosmetic reasons, and then they redistribute it to the members on weekly mixed boxes, depending of the what was produced that week. Today, the cooperative has 19 distribution hubs across Portugal, 10,000 subscribing households, and rescues roughly 27 tons of produce every week. From environmental perspective, 1 kilogram distributed avoid pointing 14 kilograms of CO2 equivalent. So basically, Fruta Feia aligns the aspects we mentioned before with economic, social, and environmental incentives in one single cooperative model. Even though Fruta Feia is well known here in Portugal, even in other European countries, uh, and in practice, academic studies about it still a little bit scattered. Uh, some papers look at the life cycle assessment and sustainability metrics, others papers usually go into the consumer attitudes, the business model itself, or the urban governance, more to smart cities as well. But there was no unified map of all those publications showing what we know, what themes emerge, and where the gaps are on those papers. In particular, the information communication technology, the digital platform they use were actually barely analyzed in the literature. And that's why we conducted this scope review to systematically collect and map all the peer-reviewed studies around Frutafeia. So our methods, we followed standard scoping review procedures. The framework was RCASE and OMIO, 5-stage process, reported with Prisma, checklist. We searched scope and web science in May of this year. Using the keyword Frutafeia without any restriction of discipline to the papers. We found 25 records identified. After screening and eligibility checks, 12 peer review papers were retained. So the review is based on this diverse body literature because it doesn't filter by discipline. From our findings from the 12 studies, we identified 80 thematic clusters. These include business models, consumer attitudes, urban governance, digital platforms, social entrepreneurship, sustainability metrics, cultural notions of freshness, and gender and equity. The most common focus is on the behavior. For example, how customers perceive, ugly, produce, or how cooperative membership change the attitudes. Just being a member, changing their behavior on outside the cooperative. By contrast, only one study explicitly focused on ICT, even though nowadays everything is digital and the platform still central pointing of the operation. So the literature is rich in behavioral insights, but there is some space to learn more about technology-centered analysis. So with that, we found some gaps. We looked across the literature, 3 clear gaps that emerged. First, metrics are fragmented because the different studies use different indicators. So it makes it difficult to compare like results between them because they have different indicators. Second, there is a lack of longitudinal evidence. The most studies are cross-sectional snapshots, so they do during a certain period. So we don't know how habits and behavior evolve over their time. And third and most important for our review is the ICT and user-centered design are underexplored. So the cooperative runs a digital platform, but almost no research examines like usability, user experience, to understand how the platform shapes the engagement or could even be improved, for example. So we already have research on food waste through gamification and serious game. So to move forward the field, we suggest drawing from another area that I mentioned, that is serious games. We made these systematic reviews showing that serious gains in gamified tools could even help reduce household food waste, and in certain cases by 15 to 30%. This is also not that clear percentage because the studies was also not standardized, but there is this opportunity. And then we can add lightweight gamify interactions into Frutafeio system and process, for example, showing feedback on CO2 saved, offering small challenge around choosing imperfect produce, or giving social badges for sustainability participation. There is a lot of opportunities here. The practical next step would be testing those ideas into different groups, cooperative members, and people who have never engaged with Frutafeia. Then we can see if the affiliation makes a difference in terms of behavioral change in sustainability. So to conclude, Frutafeia is now a mature and data-rich case of a circular economy initiative. The evidence shows clear environmental benefits, such as the 0.40 kilograms of CO2 avoided per kilogram of produce, strongly weak diversion of 27 tons, and social benefits, especially for low-income members, because they are cheaper than supermarkets. But the research remains fragmented. Metrics are inconsistent, longitudinal studies are scarce, and the ICT subject, the infrastructure that enables the cooperative, is still overlooked. That's where we see the next step, integrating and testing game-mediated engagement tools that combine behavioral science with the cooperative's digital platform. This provides a map of where we stand and points to where the next contributions can be made. So that's it. Thank you very much for the opportunity. Yeah, any questions?
Thank you so much. I have just one query. Have you considered the scalability as well as the security risk issue?
Yes, that is, we are in this phase of planning because first the security, so we don't want to, for example, expose any data from the cooperative itself that is not public already. And the scalability, we are planning to start with some pilots with 2 or 3 hubs to see, because on the scalability, there is the adoption as well. So we need to combine those 2 problems, but we still in the phase of planning, and those are topics
Thank
that
you.
we are
Thank you so
considering.
much. Thank you.
Thank you for your question.
Not from my side. Thank you.
So you will stop sharing.
Yes, you may.
Thank you for the presentation.
Thank you again.
We'll be moving forward to the next presenter, and we have Luisa Nunu with the paper titled Scoping the Progress of E-Government Services in South Africa, a journey from implementation to adoption and recommendations for addressing challenges that impede or slow down progression. And do we have Luisa here in the session?
Yes, I am here. Am I audible?
Yes, you're audible. You may please start with your presentation.
Okay, let me just share my screen. Thank you so much, everyone. Good morning. My name is Jason, and today I have the privilege of presenting a paper that I co-authored together with my colleagues, Daniel Mare and Doniso Tularo. I'm from the Council of Scientific and Industrial Research in South Africa. In this presentation today, I will be sharing our work on progress of e-government services in South Africa, tracing the chain from implementation to adoption, and also provide recommendations to address the challenges that slow down this progression. Just to provide an overview, this presentation will follow the same structure as our paper. I will start off by giving a background on e-government in South Africa, and then outline our methodology that we have used in this paper. From there, I will walk you through the key initiatives and then outline the main challenges that we have identified. I'll then share our main results of study and end off with our recommendations for concluding. E-government. E-government refers to the use of ICT, particularly internet-based tools to make government services more informative, more efficient, and accessible to citizens. The primary goals of e-government include improving transparency, improving service delivery, also enhancing citizen engagement, and also accountability for the government that's involved. E-government in South Africa traces back to the early 2000s with the official policy launched in 2001. Since then, the government has introduced several digital initiatives to improve efficiency and bring services closer to citizens. We've seen progress in areas such as online tax filing, digital identification applications, and citizen engagement platforms. At the same time, challenges remain. The digital divide between rural and urban areas, the limited digital literacy, the infrastructure gaps, and concerns about security and trust continue to hinder this adoption. It is also important to note that the role of COVID-19 acted as a catalyst in accelerating this shift towards digital platforms. To explore these issues further, we conducted a scoping review. Our search covered major databases, including the Explore and SpringerLink, while also using the words, the keywords e-government, e-government services, and e-government challenges. So from an initial set of over 1 million results, we applied strict criteria to narrow the list down to just studies. These provided the evidence and also formed the foundation of our analysis of progress, challenges, and opportunities in South Africa. Smaller or pilot initiatives were excluded to ensure relevance, the impact in the economy, and compatibility with assistance. Several initiatives are started. We have SARS defined. SARS defined has revolutionized tax administration, processing millions of returns every year. We have INATIS. INATIS central vehicle and driver licensing struggled with technical and security issues. The integrated financial management system has faced delays and cost overruns, but it continues to evolve in providing services, financial services in the economy. GovChat played a crucial role in facilitating citizen engagement during the pandemic, but participation is low due to trust and awareness issues. Affairs, on the other hand, has successfully issued over 18 million smart ID cards, but has struggled with backlogs and some security issues. And finally, we have implement portal, which aims to streamline tender processes, but almost half of those implement remains manual because of fragmented laws. These initiatives were selected, not just selected, they were selected based on their strategic significance in South Africa's governance and service delivery. They also represent major public investment. For example, IFMS alone has already exceeded 1 billion in South African rands in cost. And to also provide a balanced perspective, the review included successful cases such as and more problematic ones like the IFMS. The selection further spans a wide time from 2001 to the present time, which enabled us to trace the progression of digital governance over time. When we look across these initiatives, we see recurring challenges. Infrastructure gaps continue to exclude rural communities. These regions have discrepancies in terms of the finances and also the environment in which they are situated. Legacy systems and outdated tech, they make it very difficult to mobilize and integrate services or systems. Also, cybersecurity threats, they still highlight ongoing vulnerabilities in terms of these systems. Skills shortages and resistance to change. Within government, we have skills shortages, and within the communities, we have limited digital literacy, which further constrains the adoption of these initiatives. And lastly, we have poor interoperability, which also makes it difficult for this system to function cohesively. So what does this all mean? The evidence shows that South Africa has made significant progress in implementing e-government initiatives. We know that this system exists. This system systems provide important services across the South African economy. But adoption is still lagging behind. Infrastructure rollout, low public trust, in the citizens not really benefiting from these services. In short, is between regulation and adoption. To close this gap, we proposed several recommendations. Firstly, investing in ICT infrastructure and rural connectivity is a crucial step. And rolling out a road and facilitate the rollout of backbone through initiatives like Connect to provide lower cost of connectivity is one of the factors. And also secondly, modernizing systems and ensuring because modernizing systems between, it means that they will be able to talk to each other, communicate, so that they can share data more quickly. Thirdly, we need to strengthen cyber security through encryption. We need to add multi-factor authentication and also real-time monitoring. Fourthly, we need to promote digital literacy at both citizen and levels through training and awareness campaigns. And fifth, we need to foster public-private partnerships in order to leverage on additional fundings, because most of the time the government institutions may fall in terms of resources that are bad. And finally, we need to build citizen trust by being transparent about how these work and how we consistently deliver reliable results. Inclusion, South Africa has made some notable progress in rolling out e-government services, but adoption remains uneven due to the challenges, including a digital divide, lack of trust, and resistance to change and etc. But to unlock the full potential of digital government, it is vital to tackle the challenges that have been already discussed. And with continued investment, meaningful reforms, and stronger citizen engagement, government in South Africa can transform service delivery, make governance more inclusive, efficient, and responsive. Thank you so much, ladies and gentlemen, for your attention. I look forward to your questions and feedback. Thank you.
Thank you so much. There is no question from my end.
Thank you. Not even from my side.
Okay, I will stop sharing.
Thank you for the presentation. Now we're moving forward to the next presenter. We have George Duke with the paper titled The Importance of Business Intelligence and Power BI, the Management of Healthcare Systems, Case Study in Portugal.
Hello.
We have George. Yes.
Yes. Good morning. I'm share my work. Okay. It's visible. No.
Yes, it's good.
Is that correct? No problem. Okay. Thank you. I would like to thank you for the opportunity to attend this conference. This paper is the importance of business intelligence and Power BI and the management of healthcare systems, case study in Portugal. Authors Débora Silva, Juliana Azevedo, Ivan Claro, Lourdes Gomes, and I, George Duke. Agenda, introduction, state of the art, methodology, business intelligence and Power BI, case study, and discussion and conclusion. Let's go. Introduction. Healthcare management face increasing challenge due to the volume of clinical and administrative data, operational complexity, and the need for evidence-based decisions. Business intelligence and Power BI are strategic tools that enable you to transform scattering data into useful information, optimize resource, and monitor performance indicators in the real time. This study analyzes the impact of business intelligence and Power BI on healthcare institutions in Portugal, highlighting benefits, limitations, and their contribution to efficiency, quality of care, and digital transforming in the sector. State of the art. Recent literature highlights the growing role of business intelligence and Power BI in healthcare, transforming large volumes of clinical, administrative, and financial data into decision useful information. Studies show gains in resource planning, hospital efficiency, and transparency with Power BI value for its accessibility and ability to support data-driven organizational culture. There are, however, a significant challenge such as the interoperability of systems, data quality, privacy protection, and the short stage of specialized analytical skills. The methodology. I use the methodology DSCR, Design Science Research methodology, which makes it possible to design and evaluate technological solutions applied to health management. A system literature review and a case study in Portugal were combined with Power BI dashboards to support decision and monitor performance indicators. The SCR process took place in 6 phases, from defining the problem to communicating the results, making it possible to access the benefits, limitation, and critical success factors, and adopting business intelligence and healthcare. For example, in the definition of the problem, identify the challenge faced by healthcare organization in managing large volumes of data and the need for evidence-based decisions. The next step, the definition of the solution's objectives. To establish requirements for the application of business intelligence and Power BI, focusing on the effectiveness, accessibility, and security of information. Design and development. Configuration of interactive dashboards in Power BI with integration of relevant KPIs, hospitalization, examinations, consultation, financial management. Demonstration. Apply the developed solution in a real-life scenario, analyzing how dashboards support clinical and administrative decision-making. Evaluation. Checking the usefulness, effectiveness, and limitations of the solution, including analysis of user feedback and technical and organizational barriers. And last, communication, dissemination of results, highlighting contributions, limitation, and recommendation for future adoption. The DSCR methodology makes it possible to understand not only the benefits of applying the Power BI, but also the critical success factors and constraints inherent in the organizational context. In this way, it contributes to the deeper understanding of the potential of business intelligence to improve the efficiency, quantity of care, and sustainability of health systems. Business intelligence and Power BI. Business intelligence transforms large volumes of data into useful information to support decisions in the health sector. With Power BI, you can create interactive dashboards that improve the analysis and management of resources. In Portugal, the application of Power BI has shown gains in efficiency, transparency, and quality of care. Despite challenges such as data quality, and information protection. Business intelligence is provide to be essential for digital transformation of healthcare. Case study: Power BI application is in the National Healthcare Service. Is the process the ETL, where ETL, extract, transform, and load. The practical study as based on the creation of interactive dashboards in Power BI using data from the National Healthcare Service Transformation Platform. The appropriate preparation of the data made to possible to identify patterns, trends, and relevant indicators to support strategic decisions. Okay, is the extraction is the base is data source. Transformation the data for the objective is quality information and load the data for information. Is separate is many indicators or groups in the study. For example, financial indicators. For the dashboard presents the financial results, showing that all regions recorded negative balance with a greater impact in Lisbon and Tagus Valley. There was, however, a significant reduction in the late payments in 2024, 35%, in 2025, 257. Is a crescent evaluate the financial indicators. Is the evaluation in the financial area. In the surgical product, the surgical analysis revealed that the northern region was more efficient with shorter average waiting times and higher number of the patients treated. The Alentejo and Algarve, on the other hand, recorded longer waiting times. Is the evaluation, is the region, critical regions, okay? The organization, the region, northern region is the better organization in the service. Costs in the subsidized sector and complementary means of diagnosis and therapy. For example, there was a sharp reduction in the costs of the contracted sector 2025, 265, compiled by the predominance of laboratory tests and functional support as the main CDT expenses. Okay, is the filter for many regions. Is the evolution, the diagnostics, is the specialty and many regions in Portugal. Demographic indicators. The analysis of mortality showing that 85% of deaths occurred in people of 65, mostly males. As for the birth rate, births were concentrated in Lisbon and the north. Is the two principal regions in Portugal is Lisbon and the north, Porto, and the other regions is around of the Porto. Primary healthcare. Consultation dashboards revealed stability in face-to-face consultations between 2023 and 2024, but a sharp drop in non-face-to-face consultation in 2025. Also noteworthy was increase in home visits associated with and gaining population. Is the primary service and the principal hospital in Portugal, to Lisbon, to primary healthcare in the service. Average costs and hospitalizations. The Lisbon and Tagus Valley region had the highest average cost per patient, while the Algarve and Alentejo had the lowest figures. In terms of the hospitalizations, Lisbon concentrated the majority, but the highest mortality rate was in the Algarve. Okay, is more effectively is Algarve is the responsibility for more that. Discussion and conclusion. The Power BI demonstrates how complex data can be transformed into accessible information, modernizing health management, optimizing resource and promoting more sustainably care. The study shows that business intelligence and Power BI are important tools for supporting management in the national healthcare systems. Dashboards show important indicators, identify gaps, and support database decisions. There are also challenges such as data quality, system integration, and the need to train professionals to use this technology effectively. Business intelligence and Power BI enable management to be more efficient, transparent, and focused on improving healthcare. The guarantee sustainability result is it is necessary to combine technology, human skills, and strategic vision. In the future, they use the predictive models and continuous training could further enhance the impact of these tools. Thank you for attention. And questions, please.
Thank you for the presentation. I have one question. How are you getting my voice?
Yes.
Okay. So how you will incorporate the business intelligence in the business? Can you elaborate in a short 2 or 3 sentences?
I'm sorry.
Are you getting my voice?
Yes.
Are you getting my voice? Are you getting my voice?
I'm sorry, but I don't understand.
Are you getting my voice?
Yes,
Yes.
you are audible.
Okay, no issue. Next participant. Anisha ma'am, please continue.
So thank you for the presentation. Now we'll be moving next. And we have Zine Loriga with the paper title Toward Effective Intelligence, Real-Time Age, Gender, and Emotion Detection via Multi-CNN and MT-CNN Integration.
Good morning, everyone. My name is Zinti Lorega, and today I will present our work titled by okay. Good morning, everyone. My name is Zinti Lorega, and today I will present our work titled Toward Affective Intelligence, Real-Time Age, Gender, and Emotion Detection via Multi-CNN and MT-CNN Integration. This research was conducted with my colleagues at Sidi Mohammed bin Abdullah University in Morocco. My presentation will follow 5 main parts. I will begin with the motivation and problem statement, followed by related work before presenting the proposed model architecture. After that, I will share our experimental results. And finally, I will conclude with future perspective. About motivation and problem statement. In today's AI-driven world, understanding human emotions and demographics in real time is critical for areas such as retail, healthcare, and human-computer interaction. Most existing systems, however, only focus on a single attribute, such as age or emotion, and fail in dynamic real-world conditions like poor lighting, occlusions, and varied head poses. Our work aims to address these gaps. Early approaches like Viola Jones introduced robust but limited face detection. MTCNN improved accuracy in alignment and detection under challenging conditions. CNN then advanced age, gender, and emotion classification using datasets like UTK phase and Sika plus. More recently, transformer-based models like Swing Face and Face Xformer have been proposed. However, most remain task-specific or too heavy for real-time deployment. Our work proposes a lightweight, unified approach. Our architecture begins with MTCNN for robust face detection and alignment. Preprocessing includes resizing, normalization, and augmentation. Then three CNN are used independently for age, gender, and emotion classification. Finally, a fusion layer combines predictions into a unified profile, age, gender, emotion, confidence. This modularity ensures each classifier can be optimized independently while maintaining real-time maintaining real-time performance. About datasets, we trained our models on three benchmarking datasets. Utica face for fine-tuning age and gender, combined faces for broader generalization, Sika plus 48 for high-quality emotion recognition. This hybrid dataset strategy balances volume, diversity, and precision. As shown in Table 3, our model clearly outperforms traditional approaches and even competes with transformer-based models like Swing Face. We achieve 99% accuracy in emotion recognition and 89% in age prediction and 88% in gender classification. From Table 5, the validation metrics confirm these results. Emotion recognition is nearly perfect, while age and gender show strong but slightly lower accuracy due to dataset variability. Overall, our integrated system reaches an average of 92% accuracy while running in real time at 23 FPS, making it both accurate and practical for real-world deployment. So, in conclusion, our integrated MT-CNN model achieved 92% average accuracy in predicting age, gender, and emotion under real-world condition. Future directions include reducing dataset bias, exploring transformer-based multitask learning, and deploying on edge devices for privacy preserving real-time application. We also plan to integrate multimodal signals like speech for richer, effective intelligence. Thank you so much for your listening. And if you have any question, I'm here.
Hello. Hello. Are you getting my voice?
Hello? Yes, yes.
Okay. Can you elaborate more about the multi-CNN, how you have applied your model, the multi-CNN approach?
Please, can you repeat?
How you have applied the multi-CNN approach in your proposed model, as
Yes.
you have mentioned in your title, emotion detections via multi-CNN. So can you more
Ah,
elaborate upon it in your
okay.
proposed model?
Thank you. Okay, okay. Thank you. Great question. We trained each CNN separately, then combined them into one. So when the input we get it CNN and CNN of age and emotion and gender, we combine it in the fusion layer to give the final result.
Okay, thank you.
Thank you.
Do we have any more questions? Okay, so thank you for your presentation. And now we'll be moving forward to the next presenter.
Okay, thank you so much.
We have Sabar with the paper title Unsupervised Deep Learning for Enhanced Customer Segmentation in E-commerce, Integrating Behavior and Demographic Intelligence.
Thank you so much, Anissa. Am I audible?
Yes, you're all.
Thank you. Okay. Hello, everyone. I'm Sabar from Bina Nusantara University, and today I'm delighted to present our research title Unsupervised Deep Learning for Customer Segmentation in E-commerce. And this work integrates behavioral and demographic intelligence to overcome the limitation of traditional clustering and to discover actionable customer insights. As we know that e-commerce has reshaped how business engage with customers. However, the traditional segmentation methods such as K-means rely heavily on linear assumptions and often fail when data is high dimensional and non-linear. Customer behaviors today are far more complex, driven by both demographics and interactions such as browsing time, frequency of purchases, and product preferences. And to address these challenges, we propose using unsupervised deep learning, which can learn large structures without requiring labeled data. The objectives of this research are fourfold. First, to develop a scalable unsupervised deep learning framework for customer segmentation. Second, to integrate behavioral and demographic features, capturing a more holistic view of customers. Third, to benchmark our framework against both traditional and advanced deep clustering methods. And finally, we deliver customer segments that are not only stable, but also interpretable and actionable for business decision making. We use a data set of more than 8,000 e-commerce customers, each with 12 attributes. And the demographic features include age, gender, income, education, and location. Meanwhile, the behavioral features cover purchase frequency, average order value, browsing duration, cart abandonment, and customer tenure. This dataset provides sufficient heterogeneity to test the robustness of our approach. As we can see here, as shown in the table, the distribution of age and income is well balanced, reflecting a realistic cross-section of e-commerce users. Before training, we implement a comprehensive preprocessing pipeline. Outliers were removed using the interquartile range method, while missing values were imputed using mode for categorical data and median for continuous data. Numerical variables were normalized using z-scores, and categorical data were one-hot or ordinal encoded. Importantly, we engineered behavioral features such as recency, frequency, and monetary values, along with the product diversity in these and temporal purchasing patterns. These engineered features allowed the model to capture deeper and more nuanced behavioral insights. The core of our framework is a deep autoencoder, and the encoder compresses the input into an eight-dimensional latent representation, while the decoder reconstructs the original features. As we can see, this setup enables us to capture nonlinear relationship while reducing dimensionality also. We then tested three clustering approaches on the top of the learned latent space. The k-means applied to autoencoder features, and variational encoder clustering, and also deep embedded clustering, or DEC, deep embedded clustering, which jointly optimizes representation learning and clustering. As you can see in the figure 1, it illustrates the architecture and training process. We trained the autoencoder with the Adam optimizer, a learning rate of 0.001, and early stopping to prevent overfitting. The hyperparameters were tuned using grid search with 5-fold cross-validation. And for evaluation, we applied intrinsic metrics such as a silhouette score, Davis-Boolean index, and Kalinski-Harabas index, along with the stability metrics, including adjusted range index and normalized mutual information. This should be done to ensure that our model was both statistically robust and practically reliable. Here we compare clustering performance across methods. Baseline k-means achieve a silhouette score of 0.523, while hierarchical clustering was slightly lower at 0.487. When using autoencoder features, k-means improved to 0.689 and VAE clustering achieved 0.698. However, our deep embedded clustering approach outperformed all, with all silhouette score of 0.742, a 41.8% improvement over k-means. And this clearly demonstrates the value of combining representation learning with clustering. By doing this analysis, we revealed 6 distinct customer segments. First, we can see high-value loyalists who represent only 12% of the customer base but generate 30% of total revenue. Secondly, budget-conscious browsers, the largest segment at the 23%, but relatively low revenue contribution. And third, premium enthusiasts who willingly pay higher prices for quality. Fourth, occasional sploogers who spend heavily but infrequently. Fifth, bargain hunters who respond primarily to promotions. And finally, new explorers who are recent customers with growth potential. These segments provide rich opportunities for personalized marketing strategies, of course, as we know. And we validate the model with cross-validation and stability analysis. The discovered segments maintained 89.3% consistency across faults, with strong robustness indicated by ARI and NMI scores. From a business standpoint, applying targeted marketing strategies to these segments improved conversion rates by 23% and increased customer lifetime value prediction accuracy by 27%. And this confirms that the segments are not only statistically sound, but it's also business relevant. We can see that the business implication, there are several business implications from this paper, and it is clear for high value loyalists, we recommend targeted retention strategies. And for the budget conscious browsers, present upselling opportunities through tailored promotion. Premium enthusiasts, we need to create room for expanding premium product lines, and for the occasional splurgers are best engaged through seasonal or event-driven campaigns. And overall, these insights allow firms to deploy marketing resources more effectively and achieve measurable revenue gains. To conclude, our unsupervised deep learning framework outperforms traditionally clustering by a wide margin. It links clustering quality directly with business KPIs, uncovering 6 actionable customer segments. The impact is significant: 23% higher conversion and 27% improved lifetime value prediction. Looking ahead, future works includes incorporating temporal modeling, validating across multiple regions, and also scaling the model for the real-time deployment is necessary to do. Thank you for your attention. Looking forward for your questions and suggestions.
Thank you so much. It is a wonderful work. My concern is, have you tried with the data set collected from the different region?
Not yet.
Okay.
That is something that I need to do next time.
Okay. The second issue,
Mhm.
I mean, have you, I mean, what are the implementation challenge in your opinion? I mean, if we like to use the model, what will be the challenge we will face?
Yeah, the data availability. I think that is the most challenging. Data availability and also, yeah, I think that's the most challenging one.
Okay, thank you so much.
Thank you so much, Prof. Shamim.
Nicely presented, Sadhu. Very nice presentation, and you have incorporated, I think, all the things very nicely. All the best for the future endeavors. Uh, um, Try to, as the sir suggested, try to collect the data from different regions and then apply the test again. It will give you the better results.
Yeah, sure. Thank you so much. But I will do it.
That's all from my side.
Thank you so much.
Thank you for the presentation. So with that, we have completed all our presentations for this session. And now I'd just like to conclude the session and sincerely thank the authors for their excellent presentation and contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, we thank you for your support during this ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2026. All the presenters will be getting their digital certificates within email within 2 working days, and the communication will be live within 7 to 8 months. So kindly cooperate with the team of WS4 2025. And I would also like to thank our session chairs for chairing this session. Here is a small token of appreciation on behalf of the team of WS4 and Global Knowledge Research Foundation and partners. So Professor M. Shamin Kesar and Professor.
Thank you so much. Thank you.
Thank you so much, Professor and Dr. Navneet, Anisha. Thank you so much.
So now I will just request you all to please switch on your cameras for a quick snapshot. Okay, thank you. Thanks a lot. Take care. Good to see you.